Hello, Algebra 2 trig students. Today we are going to learn about operations on polynomials, specifically addition, subtraction, and multiplication. We're going to save division for another day. Before we start talking about operations on polynomials, let's talk about what a polynomial is. Polynomial is just a bunch of terms added together. So I have examples down here of all polynomials. A polynomial simply is a mathematical expression made up of terms that include variables raised to whole numbers and multiplied by coefficients. So there are some things that are not polynomials. For example, x to the minus 2 plus 3, not a polynomial. It has a negative exponent. Or the square root of x plus 1 is not a polynomial. It has a fractional exponent. Or 1 over x plus 2 is also not a polynomial. It has a variable in the denominator. All the expressions written down here are polynomials. All the variables have powers that are whole numbers. I sometimes have a coefficient out in front. These are all polynomials. Now, polynomials are of different types. The first type is a monomial. It's defined to be an integer, a variable, or the product of an integer and variables. So there are two down below here that are monomials. This one and this one. As you can see in both of them, it's just a term. I have a number or a coefficient multiplied by a variable. I have a number multiplied by variables, all raised to whole powers. They're both monomials, so you don't see an addition or subtraction sign in there. The next type is a binomial. It's defined to be the sum or difference of two monomials. So looking down below, I see the first one is a binomial. And that's one more over here. This is also a binomial. It's the sum or difference of two monomials. Here's a monomial, monomial. I'm adding them. Monomial, monomial. I'm subtracting them. The next type is called a trinomial, and it's defined to be the sum or difference of three monomials. So this is a trinomial. This is a trinomial. Again, all polynomials, but different types based upon the number of terms. I can also classify polynomials by their degree. Now, before I go on, the degree of a polynomial is the highest power on a variable when in standard form. In other words, all multiplied and simplified. And they have special names, some of them. So again, we can classify based upon the degree, the highest exponent in my polynomial. So let's look at the names for each of these types. If I look at the first type, it's 0. And you can see there's no variable there, but if I want to pretend there's a variable, it's definitely to the 0 power, because anything to the 0 power is 1. This type is called a constant. The next one, I think you probably know. If you take a look, the highest power on this is 1, degree 1, and we call this linear because it graphs a line. We just finished a study all about this type. The highest power on my variable is 2, and this is called a quadratic. The next type has the highest power on my exponent is as a 3, and that's called a cubic. In this one, the highest power is a 4, degree 4. This is a quartic. And in the last one, the degree is 5. We call that a quintic. Now, the standard form of a polynomial has all the terms arranged in decreasing order of power. So the first thing that I'd like to do to these is change them around. So if I look at my first one, my highest power term is x to the third. I'm going to move that in front. The next is highest power is a 2. Then I have minus 8x plus 5. Now that is standard form. You should be able to look at this and see that the degree is 3, and therefore it is a cubic. Next, I'd like you to try the others. Press pause on your video, give them a try. When you're ready to see the answers, press play again. Here are my answers. As you can see, I've arranged all of these in decreasing order of power, and I've classified them. This was degree 5, it's a quintic. Degree 2 is a quadratic. Degree 4, quartic. Degree 3, cubic. And degree 4, quartic. Now that we've done that, we are ready to start adding and subtracting polynomials, and it really is not a problem. All you have to do is remember you're combining like terms, and like terms have all the variables the same to the same powers. That's the only way you can add or subtract them. So I'm going to do a couple with you, and then I'm going to have you try some. So let's look at the first problem. Now you'll notice I'm adding these polynomials. There's a plus sign in here. But really when I'm adding, these parentheses do not do anything at all. So I can pretend that they're not there, or I can make another step and just remove them. Now the idea is I want to combine my like terms, and as you look at this, you should see, let's see, I only have one x to the third term, so I'm going to put that out in front. It's my highest power. The next term, next highest power is a 2, so I want to take the negative 2x squared and the negative 3x squared, add them together. That would be negative 5x squared. And now, let's see, the next term should be my x term. So I have a 3x minus a 2x. So that should be just 1x. And then I have minus 2 plus 9, which would give me minus 11. Decreasing order of powers. Now notice my instructions also ask that I classify it by degree. My degree here is 3, and therefore it is a cubic. Now, when I'm subtracting, it changes things a bit. The only thing that changes is that this negative needs to get distributed to the inside before I start adding. So I'm going to do that first. Distributing the negative gives me a plus 3x cubed minus 2x squared and a plus 5. Now I'm just going to arrange my terms from highest to lowest, combining my like terms. I only have 1x to the third term, taking care of that. And then my next highest power term are x squared terms. And I have 6x squared minus 2x squared. So that would give me 4x squared. Taking care of those. I only have one term that has just an x to the first. That's that guy. And then I'm going to add my 2 and my 5, 7. And now the highest power is 3. That's my degree. And it is a cubic. Notice how I kept track of what I was at, the like terms I was adding together. It's really easy to miss one, so you got to come up with some kind of method. I generally cross them off. Now I would like you to give these 3 problems a try. Remember, in the end, I want you to arrange the terms from highest power to lowest power. Press pause on your video. When you're ready for the answers, press play again. Take a minute to look at each of these. Check if you got the right answer. If you did not, see if you can track down where your problem is. Remember, when you're distributing this 3, it's a negative 3. That gets distributed to the inside. Same thing here. When you distribute a negative x squared, the negative goes with it. Now that we've added and subtracted polynomials, our next operation that I'd like to look at is multiplication. And you have multiplied binomials together. Remember the whole FOIL process. Now, though, we're going to multiply polynomials that may have more than 2 terms in them. And really, the process is quite simple. You distribute the first term and then distribute the second term. If I'm dealing with 2 quadratics or something with 3 terms, I distribute each term separately, and then I combine my like terms. And I like to organize it a certain way that has really helped me minimize the number of errors that I made. So I'm going to show you how that works. So let's do the first one. Let's distribute that 3x. That gives me 3x cubed. Remember, if I'm multiplying with variables, I'm adding exponents, minus 3x squared minus 3x. Now, I could keep going with this negative 2 and list the rest of the terms that way. But one thing that I've found is helpful is to distribute this and line up my like terms one on top of the other. So then I can simply add straight down. So I'm going to do that with the negative 2. Distribute the negative 2 to the x squared. That gives me minus 2x squared. Notice I put it under that like term, negative 3x squared. Now distribute the negative 2 again. That gives me positive 2x. I'm lining up my like terms. Distribute the negative 2 again. That gives me plus 2. And then I'm going to add them together. 3x cubed straight down, minus 5x squared, minus x plus 2. Now, read your instructions. It also says to classify based on the degree. My degree here is 3, and it is a cubic. Okay, so now let's look at the last one. I have 3 terms to distribute, and I can do so this way, or I can distribute the other way as well. No matter what I do, I will get the same answer. In this particular case, I'm going to distribute from the left into the right. So let's distribute that x squared in. That gives me x to the 4th minus 4x to the 3rd plus 3x squared. Now I'm going to distribute the negative 3x. That is minus 3x to the 3rd plus 12x squared minus 9x. Now distribute the negative 2. That gives me minus 2x squared plus 8x minus 6. And now I can add straight down. I have x to the 4th minus 7x cubed. 3 plus 12 is 15 minus 2 is 13. 13x squared minus x minus 6. The highest power is my degree. My degree is 4, and therefore this is a quartic. Be very, very careful as you're distributing, especially watching for negative signs, because it's very easy to make a mistake. Next, I'd like you to give these 4 problems a try. Again, being very, very cautious with your negative signs and showing all of your work will definitely help there. Before you get started, notice there's 3 things getting multiplied together. You have to do slow and steady wins the race. Multiply 2 at once and then multiply the result from this to that. All right, so pause your video. When you're ready to see the answers, press play again. Here are my answers. Again, notice you have to multiply, when you have 3 together, multiply 2 and then multiply 1. In this particular case, I distributed from right to left over here just because I wanted less rows. But either way you choose, you will get the same answer so long as you don't make a mistake. So if you did not get these right, see if you can't find where your error is. And when you're done with that, check out the assignment that I have for you online, and have a great day.